Want to know why? Ask how. Howard the Humongous. Remember, once upon a time, roughly 3.85 billion years ago, there was only a teaspoon of life on this planet. And that teaspoon was up against a deadline. In its future were 142 mass extinctions. Mass extinctions caused by, guess what? By nature. Yes, by Mother Nature herself. To beat the next cataclysm, the first teaspoonful of life had to fan out into the wilderness of chaos and catastrophe. It had to generate as many new forms as possible. It had to invent as many new ways of eating its environment as it could. And it had to turn as much pristine matter into life stuff as possible before the first mass extinction could stop it in its tracks. In other words, that tiny teaspoonful of life had to kidnap, seduce, and recruit as many dead molecules as it could and insert those dead molecules into the fragile enterprise of life. It had to find as many cracks, crevices, and creases as it could in which to survive, and to do more than merely survive, to thrive. That's when bacteria, your foremothers and mine, began to desecrate the gorgeous virginal glasses churned out by volcanoes. But the plunderers were not impressive. In fact, they were appallingly mundane. They were a mere 2 microns in size, 2/millionths of a meter, a 40,000th of an inch. Some looked deceptively ordinary. They were tiny, frisbee-like discs. Some were a bit more distinguished. Their surfaces were wrinkled, and others were bacillar. They were shaped like sausages. But these harmless-looking little things were more disruptive than they looked. They were capable of clawing nature and slashing their surroundings. They were endolithic. They invented new ways to live inside of rock. And they were chasmoliths. They perfected the art of living in cracks, fissures, bubbles, and the micropockets called vesicles, which means that these professional looters sought out weaknesses, tiny fractures, hairline cracks. Then they invaded, they penetrated, and they made the cracks and fractures bigger. To put it in environmentalist terms, they ravaged, pillaged, and raped. They were also masters of colonialism, imperialism, and manifest destiny, virtuosos of the development of real estate. They built homes, not just individual homes. They built architectural structures that housed entire colonies. They built the equivalent of domes enclosing entire nations. Some microbial armies constructed tubes of titanium oxide to house their metropolises. Some built capsules and sheaths. Others laid down massive platforms, bedding planes, 5 to 10 microns thick, on which an entire colony could settle down, a colony of 7 trillion, more than all the humans who have ever lived on this planet. Those platforms were embedded with primitive data networks, chemical data webs, and these bacteria became masters of material engineering, like concrete craftsmen impregnating their slurry with gravel. The platform makers strengthened their building material by mixing in aragonite, calcite, gypsum, quartz, and halite, minerals stolen from their innocent environment. This was materialism taken to the nth degree. Some platform makers went farther. They manufactured a construction material with the sort of molecular structure we use in plastic, polymers. We make our plastic by linking identical molecules of hydrocarbons in long chains. But bacteria cranked out their polymers, their plastic, by linking long chains of identical sugar molecules. What technological hubris! Tubes of titanium oxide, polymer sheets, bedding planes. Surely these were Franken products, things that had never existed in nature, things that should never have been. The bacterial manufacturers of these unnatural chemical constructions ravaged the untouched nakedness of the volcanic glasses and the rest of nature's pure rock face. Some microbial societies used their polymers to turn tiny tunnels, 5 to 10 microns long, into communal homes. Other bacterial infrastructure builders produced what we call biofilms, thin film coatings that housed entire colonies, or films that functioned like rainforests, housing colonies of multitudinous species, a plethora of colonies, of different kinds of microcreatures that worked together to do their thing. These biofilms were so flexible that they could graffiti every wrinkle of the underside of a complex, irregular, pumice-encrusted surface, clinging to it as skin-tight as spray paint. The colony building was ugly. Some invaders manufactured an ooze, a gel within which the entire community of colony members could hive. Others mass-produced another kind of semi-liquid protective material in which to establish their housing tracts, slime, and some oozed a noxious sludge that required a complex chemical trick, a materials engineering high-wire act, a metabolic strategy, an industrial process called fractionation. Fractionation is the process that we would someday use in oil refineries. It produces foul-smelling wastes. The end product for bacterial fractionation was a black, sometimes solid, sometimes liquid hydrocarbon called bitumen, a pollutant, the stuff from which we get oil and natural gas. In other words, the first life forms used the sort of industrial processes that we are taught to loathe, the sort that we call environmental nightmares. But the life forms that showed up to eat what volcanic and tectonic conflict had produced were not satisfied creating environmental outrages in the cracks of volcanic glass. They also invaded the volcanic sands and dusts in between these jewels. They infested individual sand particles in the vicinity. They invaded and colonized the space between the particles, and they went beyond the sands, overrunning and plundering the tiny bubbles in volcanic rocks like pumice. The first generations of glass, sand, and stone invaders were rough riders. They figured out how to live off the land. Technically, they were called autotrophs. They did not need other life forms to lay a path and make things easy for them. They themselves were the creators of new paths. They were the pioneers and thugs that specialized in kidnapping, seducing, and recruiting truly dead atoms and knitting them into the process of life. And they had no sense of reverence, limitations, or deference. They corroded raw glass and rock. They snatched dissolved carbon dioxide from the water of the seas and pocketed the carbon molecules that they needed to knit protein, cell walls, and DNA. They pried atoms of iron and manganese out of the volcanic glass, cemented them into their own bodies, and used them as electron donors. They kidnapped, seduced, and recruited atoms of sulfur dioxide from the seawater and used them as electron acceptors. Meanwhile, their cousins grabbed virgin methane and hydrogen sulfide emerging from seafloor seeps and used them for food and fuel, thus advancing the common project of life. The volcanic glass looters, methane eaters, and hydrogen sulfide swallowers were not alone. They had trillions of distant relatives. The descendants of the first teaspoonful of life turned themselves into a vast family of life forms that insinuated themselves wherever they could invade. This extended family of plunderers specialized in twisting nature's arm and distorting her beyond belief. This extended clan specialized in upsetting nature's balance by turning nature's tortures into treats. Bacteria feasted in the abyssal plains that cover vast stretches of the deep. They feasted nearly 4 miles beneath the surface of the sea, where the temperature was just above freezing. They feasted in the inconceivable depths, where it can be extremely cold, utterly dark, often low in oxygen, and smothered by a pressure 1,000 times greater than at the surface, a pressure so immense it alters biochemistry. Yes, bacteria ate their fill in pressures so immense that their massive crush alters biochemistry itself. And this ravenous horde feasted in deep water plumes, where the thermal weather is like a deep fat fryer engulfed in flames, plumes where the temperatures were from 250 degrees to 700 degrees Fahrenheit, nearly 500 degrees above the boiling point, hells where only the mash of pressure kept the water from turning to steam. This gang of bandits also feasted near 18-story high undersea chimneys of heat and chemicals called black smokers, and the clan sated its appetites around heat vents with a very different chemistry, whose dominant colors were not black, but white and gray, spires and cliffs, where the hordes of microorganisms tunneled the porous channels and crevices of the carbonate towers, where they attached themselves in polymer-encased biofilms to the outsides of the chimneys, where they established footholds in the chimney's dark, oxygenless insides, and where they formed disgustingly mucus-like, dense strands of filamentous bacteria in the warm fluids issuing from the summit. But these invaders didn't just adapt to the way things were. They adapted to the way that things refused to stay the same. They adapted to nature's very backbone, change. Says the University of Washington team that explored the Lost City hydrothermal field 12 miles west of the Mid-Atlantic Ridge, quote, results from next-generation pyrosequencing show that the archaeal and bacterial biofilm communities underwent dramatic changes as environmental conditions in the chimneys changed over a 1,000-year period. English translation: bacteria, like those in the Lost City field, surfed the waves of insult, threat, and instability. How did communities of mere microorganisms ride the tide of environmental pitch, plunge, and sway? They reveled in ripping up the natural order and putting it back together again in whole new ways. They reveled in transforming impossible environments into paradises. Bacteria like those of the Lost City hydrothermal field even used the chemical energy of rock emerging from the staggering pressure within the earth and decompressing, the, quote, serpentization reaction within the Atlantis Massif, close quote, to pull off, quote, abiotic hydrocarbon production, close quote. Voracious bacterial colonies seized dead carbon and hydrogen atoms and compacted them into a comfort food for specialized eaters called methanotrophs. That meat and potatoes for these gourmet microbes with an offbeat taste was methane, 1 carbon and 4 hydrogen atoms. Methane is the core ingredient of what we call greenhouse gas or natural gas. It is a greenhouse gas. It is a climate warmer. The clans of microbial plunderers paid no attention to the fact that nature rebuffed them in every conceivable way. They were disaster riders and catastrophe tamers. They worked in waters almost as acidic as the caustic stuff that you pour down your drain to unclog it. Liquid plumber. These audacious bacteria worked where, quote, mantle rock has been thrust up through the seafloor, exposing it to seawater and serpentization, close quote. They exploited and desecrated the chemical-rich water that oozes from the seafloor around the edges of continents. They even invaded 1.7 miles beneath the surface of the stone at the bottom of the sea and drew their energy from chemical compounds, hydrogen and sulfates, produced by the decay of radioactive elements in the rocks. Yes, you heard that right. Some bacterial colonies invented techniques with which to harvest the fruits of a deadly poison, radioactivity. Others invaded seamounts, the peaks of undersea volcanic mountains, where up to half the species that showed up to plunder the place rejiggered their genes and invented utterly unique adaptations, utterly unique ways to turn their innocent environment into Frankensnacks and grotesque treats. These peak conquerors also invented utterly unique new bodies, new species that showed up no place else on Earth. They are still inventing new forms and new ways to eat their environment today. In fact, in some extreme environments, there is at least 100 times greater species diversity than scientists had expected. 100 times more techniques, tricks, and tools for exploitation than we thought. 100 times more forms of opportunism and innovation whose instruction manuals are written into strings of genes. 100 times as many ways of violating the status quo with biotechnologies. 100 times more forms of materialism, consumerism, and waste. 100 times more ways to despoil the virginal and the pristine. How in the world did the first teaspoon of life take hold on a planet of climate catastrophe? Life's secret will not come as a surprise. Life did not triumph by living in harmony with its environment. Far from it. Life survived by lashing out against the natural order. Life survived by sinning against nature and inventing a freak farm of Frankenforms. Frankenforms able to eat the roiling disaster of their environment and turn it into biostuff. Life survived by radically reinventing the hell of stone that nature had made. In fact, life survived by remanufacturing the planet, remaking it right down to its very chemistry. This is Howard Bloom, speaking to you from the future. It's your job and my job to make. Tune in for the next adventure of these savage, snatching, tearing bacteria that remade the nature that we know today.